squirrel. So majestic. It would be a real shame if someone were to say, "Get off my property!"
Well, would you look at that? The whiteboards are back. I wonder why. Probably because you guys liked the first one so much that I've been asked to do another one. So hopefully you enjoy. But anyway, we're going to be talking about acids and bases today. Now, the main characteristics of an acid are that they taste sour, turn litmus paper pink, they may dissolve a metal, they will donate hydrogen cations or protons, and most of them contain a bonded hydrogen atom, which is released to yield cations and anions in water. Now, the main concentration of said acid is that the hydronium is greater than the hydroxide. Examples of this are orange juice and hydrogen peroxide, which we'll be using later. Now, anyway, moving on to bases. Bases are characterized by tasting bitter, turning litmus paper blue, they feel slippery, they will release a hydroxide OH ion, and they will accept hydrogen cations or protons. Now, pretty much acids and bases are the exact opposites of each other, which is why they neutralize each other. But anyway, the concentration of a base is that the hydronium is less than the hydroxide. Some examples of this are egg whites and the yeast we'll be using later. Furthermore, neutral solutions, they tend to not affect litmus paper, and they tend to be harmless. And normally, that means that your hydronium is equal to your hydroxide. Examples of this are water and sodium chloride. But anyway, you're probably wondering, how do I use this for calculations? Well, you don't. You have to calculate the pH, which is what we'll be going into right now. So, the pH is actually just the measure of hydrogen ion concentration of a solution, which is defined by this equation. pH is equal to the negative log of your hydronium molarity. Now, normally, in an equation, you'll be either given the hydronium or the hydroxide molarity. In the case that you are given the hydronium molarity, you plug that directly back into the equation. But in the case that you're given the hydroxide molarity, you have to plug it into this new equation to find the hydronium molarity, which is defined by hydronium is equal to 1.0 times 10 to the negative 14th divided by your hydroxide molarity. Now, the pH scale normally ranges from 0 to 14, with your acids being 0 to 7, your neutrals being 7, and your bases being 7 to 14. An example of this is found here. The equation states, what is the pH of an aqueous solution having a hydroxide molarity equal to 5.0 times 10 to the negative third? Well, remembering the original equation of pH equals the negative log of your hydronium concentration, we have to determine what our hydronium concentration is. Using that equation, H3O is equal to 1.0 times 10 to the negative 14th. We have to divide that by 5.0 times 10 to the negative 3, which is equal to 2.0 times 10 to the negative 12. Quick maths. We then take this new number and we plug it back into the original equation. pH is equal to the negative log of 2.0 times 10 to the negative 12, which is equal to 11.70. So now that we're done with the technical stuff, let's go blow something up. Yee. So before we go blow something up, we want to show you what the elephant toothpaste experiment should normally look like. Right? So we have our hydrogen peroxide and some soap in this bottle, and we have our yeast here. So once we put our yeast in here, see it, yeah. See, it's just too anticlimactic. It doesn't really do as much as we want it to. So we're gonna go try and launch this as a rocket. See you in a bit.
It's oozing, ooh!
Okay, so now that we're somewhere safer, in the middle of Sierra, we're gonna try and launch this rocket. Now, what we need to do is we gotta get this yeast into this balloon, right? So we're gonna hopefully not spill any into the rocket itself, because if it goes in, we're screwed. All right, so this should hopefully fill it up.
Gonna speed this up. Post recording. How much money can I spend here? It's not going into the ball, right? Ah, shit, I forgot there's a burger in the fridge. Should I put that in the recording? Ah, shit, I forgot there's a burger in. Well, room's full, dog. Like it's full.
All right, so let me put these goggles on so I don't die. All right, so the whole point of this is to hopefully get this cap on before the yeast reacts with the hydrogen peroxide. So, all right, that went pretty well actually. All right, so now all we gotta do is shake this pupper up, and it's actually really hard and hot. So hopefully this goes good. You ready to?
お前はもう死んでいる。何?
Oh shit, it's gonna pop.
Where'd it go? Oh, it's over there.
That hurt! Ah, my arm! Now that we're back, I'm gonna try to explain to you what just happened. So, hydrogen peroxide is an unstable molecule that normally breaks down into water and oxygen over a long period of time. It is also an acid. Yeast, which is a base, is considered a catalyst in this situation because it's gonna speed up that reaction. Now, because we're getting a lot of this oxygen gas and we're getting all this water coming up all suddenly, the soap that we poured into the hydrogen peroxide is going to be affected by the release of our oxygen gas, causing this great foam to come up, which we'll just call toothpaste because that's what it looks like.
And now, the bloopers and credits.
No, Mike, don't. I ripped that board in half.
Squirrel's back. I thought I told him to get off my lawn. We're gonna have to take things up a step. Wait! Where are you going? I'm not done talking to you.
Well, I forgot to put the gloves on too. Yeah, boy!